In our first section, we're covering how to interpret graphs and figures. Since this is such a critical section, we're going to break this apart into 3 different videos. In the first one, we're going to look at interpreting figures. In the second one, graphs, mostly line graphs. And then the third one, we're going to look specifically at interpreting bar graphs. So the first one, problems 1 through 3, use the map below. We have soft drink descriptions by state, highest percentage reported. What we're doing is we're taking a look at what do people call beverages. So they call it pop, Coke, or soda based on geographical distribution. So question 1 says soft drinks are described as pop in what percentage of states? First thing I want to do is I want to take all my data here, this pop, Coke, and soda, and I want to attach some numbers to it. So I went ahead and I added up all of the darker states here that have pop, and that was 20 of them. The ones with the lines on it, that's Coke, there's 10 of those. And then the kind of the grayish ones, that would be the soda, there's 18 of those. So soft drinks are described as pop in what percentage of states? I did 20 divided by 48. We don't have any data for Alaska or Hawaii, so we're only including the 48 states. They want it as a percent, so I'll put that in my calculator, convert it over, and I get 42%. Question 2 of the 48 contiguous states shown. So again, same data, just a little bit different way to state it. What percentage of states describe soft drinks as Coke? So Coke is 10 of 48. So we're looking at 21%, which is exactly half of what we're looking at in question 1. We expect that. Half the states preferred to call it Coke versus pop. And number 3, complete the following sentence with the correct order of words. Basically what we're looking at is the distribution of how people say it. So the first thing we're looking at is the middle and western portions of the United States. So back at the graph here, the middle and western portions is all in this area here. It's very heavy with pop in that case. So pop would be the most prevalent way to describe it. For some reason they call it soda in Wisconsin. That kind of stands out as an oddball. Then we're looking at southern states. So southern states are the ones down in here, with the exception of New Mexico and Florida. Looks like, generally speaking, they're going to call it Coke. And then that would leave soda, but let's just make sure. Northeast and southwest, yeah, definitely going to be soda for that. So correct answer there would be pop, then Coke, then soda, which would be choice C. In our next figure, we're looking at a pie chart. And in this one, Margot surveyed all the students in the government classes at her school, to see what they thought should be the most important concern of a national government. And the results of the survey are down here. So we had others 5%, healthcare at 9%, unemployment at 14%, education at 16%. In question number 4, it says if 400 students were surveyed, how many felt healthcare should be the most important concern of a national government? We should expect a whole number, something very, very close to that. We're looking for 9% of the total. So to do that, I convert 9% to a decimal, and that's 0.09. I multiply it by how many students were surveyed, and that's 400, to get 36 students. Number 5 says 35% of students felt foreign policy should be the most important concern. What percentage felt the environment was the most important? So figure out what we had left, what we had already used up. It looks like we've used up 44 of our percent of people. So total we have 100%. So I know I've got 56 left between foreign policy and environment. 35 is foreign policy. That means 21% would have to be for the environment. And which of the following are among the top 3 national government concerns in the government class? Definitely foreign policy, definitely environment. Looks like education would round out the third. In our next problem, we're looking at kind of a scatter plot here. It says 4 different classes at Corbett Elementary School participated in 2 fundraisers last year, one in February and one in May. And the rates of participation for each class are recorded below. Now this is kind of an unusual unusual graph because we're comparing percentages on that same graph. Normally we have an input on the horizontal here, and then we have an output, but participation in May was not necessarily an indicator of participation in February, so it's just kind of comparing the 2 quantities. So let's think about what this is saying here. If we had point A, what that is saying is that Class A, in May, 60% of the students participated as did that class in February, 60%. Point B, 70% participated in May, 80% in February. Point C, 70% in May, 50% in February. And then point D, or class D, 90% in May and 90% in February. So number 7 says, using correct units, describe what point A means in the context of the scenario. So again, students in class A participated in both of the fundraisers at a 60% rate. Number 8, which class had the greatest change in percentage participation from February fundraiser to the May fundraiser? So really what I did is I just said, all right, well, let's compare them. A was a 60 and a 60, so that's a 0 change. Class B, we went from 80 to 70, that's a minus 10. Class C, we went from 50 to 70, that's a plus 20. And in Class D, we went from 90 to, we stayed at 90, so there was no change there. So plus 20%, that's the largest percent change in any of those participations. And if there were 20 students each in Class A and Class C and 30 students each in Class B and D, how many participated in the May fundraiser? So again, the May fundraiser is this one right here. Class A participated at 60% rate, so 60% of 20 is 12. Class C was at a 50%. 50% of 20 is 10. Class B, there were 30 students, so we had 30 students at an 80% rate, that's 24. And then for Class D, we had 90% participation of 30, so 27 students. And I added all these up and I ended up getting 73 for my choices there. And last one we're going to look at is this one with reading a novel. Tony's reading a novel. Table below shows information about the novel, his reading speed, and the amount of time he plans to spend reading the novel each day. A couple of things that jumped out at me was he's going to plan to read the novel 3 hours per day. And that's going to be useful information later. There's also a lot of pages in there, 1,078, 349,168 words. Okay, and there's giving us a lot of different things that we can do. We do have a rate here. Tony reads at 250 words per minute. So number 15 says, on average, how many pages are in each part of the novel? So we take the number of pages that we have, which is 1,078, and divide it by how many parts there are, and that will tell us our average, rounded to 1 decimal place, 134.8. Number 16, on average, how many pages are in a chapter? So we look at the number of chapters, the number of pages, 1,078, divided by the number of chapters, which is 239. It's about 4.5 pages per chapter, which seems like a very small number, but it's got 239 chapters, so there you go. Number 17, on average, how many chapters are in each part of the novel? So we're looking at number of chapters, 239, divided by the number of parts, which is 8. We'll get 29.9. And then really when we get down to me, this is kind of the cool part. What's the closest number of days that it would take Tony to read the entire novel? So what we're going to do is figure out how many words per day is he going to read. And to do that, we'd figure out how many words per hour is he going to read. We already know that he can read 250 words per minute. Then he's going to read for 60 minutes. That would give us 15,000 words every hour. He's going to read for 3 hours a day, so if we take that 15,000 times 3, that's going to give us 45,000 words every day that he's going to read. And then we want to know how many days is it going to take, so we take the total number of words divided by his words per day, and that would give us 8. So that's how we're going to interpret figures. It's just, reading tables, reading pie charts like we had up here, reading these little comparison graphs, and then things like pictures. And in part 2, we're going to look at line graphs, and then part 3, we're going to look at bar graphs.